even though this problem asks us to use a graph to solve this equation, I'm actually going to solve this algebraically just to show you how easy that is to do. At the end, I'll remind you how we have used graphs in the past to answer these questions, but let's start with just solving this algebraically. So I'm given an equation right here that tells me how long it takes a pendulum to swing back and forth, that's called the period, if it has a pendulum length, a string length, whatever, that's L feet long. So don't worry about the physics behind this, we're just doing math right now. But let's see, the question is, how long is the string going to be, or how long is the pendulum if the period is 3 seconds, if it takes 3 seconds to swing back and forth? So because that 3 seconds is the period, that's the t value according to my equation. So I'm going to write algebraically, I'll write a little formula equation down here. So 3 is going to equal 1.11 times the square root of L, and L is going to be the length of the pendulum. So let's again solve it algebraically just to see how easy that is, and we'll take a look at the graph. So I'm going to start by dividing both sides by 1.11. I want to get that square root part isolated. Using a calculator, that comes out to be about 2.70 or so, times the square root of cursive L. So if I want to get the L by itself, right now I have the square root. So to undo taking the square root of something, let's just square both sides. That'll cancel this out. So once I square 2.07, I come up with about 7.29 as the length of L. Since this was a story problem, we want to make sure we have a good label. It's set up in our directions that was measured in feet. So I have a pendulum that's about 7.29 feet long. So algebraically, that's all I'm going to do, and I'm fine with you guys doing that. Let's switch over to the calculator. I'll remind you about some things on there, some ways to solve this graphically. So we've already solved this equation algebraically, which I'm totally fine with. I think it was easy enough to do. But just to solve this graphically, just to remind you what we did, I want to go ahead and enter both sides of my equation as two separate equations. So in my graphing calculator, pause the video if you need to catch up with me real quick, I've entered in the two sides of the equation. As y1, I've typed in 3, and I kind of wrote that over here for my work. And then as y2, I entered the other side of my equation, 1.11 times the square root of L, or x in this case. And so what I want to do is graph this, and I want to find the intersection of these two graphs. So let's take a look and see if we can see an intersection. There's the line y equals 3, it's horizontal, we should know that. And there's our square root graph. It's got that basic hook shape that we've talked about. And I can see that, yes, I do see the intersection on the standard window. If not, I'd have to adjust my window. So as we've done in the past, let's hit second trace to get to the calculate menu. I want to select option 5, intersect. All you need to do is trace over, just use left and right arrows to trace over close to that intersection point, and then just hit enter 3 times to answer the 3 questions they're asking for. So the first curve, we're on it, hit enter. Second curve, it's on it, and then guess, just go ahead and enter. And there we go, we come up with an answer of about 7.3, which is pretty darn close to what we found out algebraically. So there's 2 ways that we can answer this question.